Hello everyone, my name is Tadessa. I'm a lecturer and an NLP researcher. Today I'm here to talk about our work, that is impacts of homophone normalization on semantic models for Amharic. This paper is accepted to present on the third international conference on ICT for the development of Africa, ICT for 2021. And the author of those papers are me, I'm Tadessa, and Abdul Ali, Gete Galay, Said Mohe, and Chris Bemenen. As introduction, for your information, Amharic is a Semitic language family, and this is the second most widely spoken Semitic language after Arabic, and it's used as the official working language of Ethiopia. And Amharic uses Ge'ez alphabets, which are called Fidel. It adopts 26 basic characters from Ge'ez and creates another 8 characters, and a total of Amharic has a total of 34 basic characters. In Amharic writing, there are different characters that have the same sound but different in shape and usage, which are called homophone characters. So this research is focused on those homophone characters, and those homophone characters are those 4 types of ha sound, 2 types of a, 2 types of s, and 2 types of characters, along with their 7 derivatives. When we see the current trend in Amharic NLP research, the trend is normalize those homophone characters into a single representation. That is, for example, instead of those 6 or 7 types of ha, use one single ha. Instead of those 4 types of a, use a single a, and so on. When we see the reason behind those homophone normalizations, there are different assumptions from different scholars. Among those, there is an assumption that normalization will make the NLP task easier. Homophones interchangeably used trend, especially the online community. The online peoples are mostly used those homophone characters randomly, and there is also an assumption that they are redundant alphabets. The difference of their shapes and others, there is an assumption that they are redundant alphabets. So our motive to do this work is that the normalization trend is not research supported. The previous normalization trend is not research supported. No common stance among NLP scholars regarding normalization. Some of them support normalization, and some of other scholars are not support. And how normalization affects NLP application is not well studied. And lastly, do we need text normalization? If so, for what types of NLP application? Maybe homophone normalization depends on the application that we have developed. For this research purpose, we have collected moderate large corpus from different available social media sources. We have collected around 106 million tokens from 6.8 million sentences, and to develop a specific NLP application, we have obtained named recognition, part of speech tagging, and sentiment analysis datasets from previously conducted researches. So after we have collected those different corpus and level datasets, we have developed different Amharic pre-processing tools. We have developed corpus cleaning because the collected corpus is not ready-made to develop models, and we have developed a flare-based Amharic sentence segmenter and word tokenizer, and we have developed frequency-based homophone normalizer because we have developed our models using homophone normalization and using regular text that is unnormalized, and we have developed stop word removal and abbreviation expansion, and lastly we have used the Python compact language detection that is used to filter only Amharic sentence scripts. And after we have applied different pre-processing tools, we have built different embedding modules or language modules in regular and in normalized approaches, because we have intended to study the impacts of homophone normalization. So we have developed static word-to-vec and fast text with their CBOW and scriptogram architectures, and we have developed contextual Roberta and Flare embeddings. Those, as we know, that Roberta and Flare contextual embedding is GPU-based running, and we used GPU to develop those contextual Roberta and contextual Flare embeddings. And after we have developed different language modules or embedding modules for the utilization of those developed embedding modules, we have built different Amharic and NLP applications. For the typing in this work, we have developed those 4 types of Amharic NLP applications, that is part-of-speech tagger, named entity recognition, sentiment analysis, and IR, that's information retrieval. And we used for sequence leveling tasking, that is part-of-speech tagger and named entity recognition, we used BLSTM with a CRF, that's BLSTM with CRF to address sequence leveling tasks, because it is the current state of that algorithm to develop sequence leveling tasking. CRF stands for conditional random field. For sentiment analysis task, we used LSTM document classifier algorithm, and for information retrieval, we used Elasticsearch indexing tools. When we come to the discussion result and discussions, the first task that we have done is part-of-speech tagging, and the result is shown in this table. As you can see from the table, part-of-speech tagger from regular Flare and regular fast text CBOW performs better. And as we have analyzed from the test file, misclassified tags are not due to homophone variations. In contrast, words with homophone variations at regular and at normalized is correctly predicted. And the second task that we have addressed is named recognition, and that the result is shown in this table. And the result shows that named recognizer models from Flare, that means from regular Flare, is outperforms other models, and from the normalized one, fast text CBOW performs better. And the third one is sentiment analysis. And as you can see from this sentiment analysis table, in all cases, regular models have better performance than the normalized one. And the error analysis from the test file shows that tweets that are correctly classified in regular models may not classified correctly in the normalized one. And the last one, Amharic NLP application that we have addressed is information retrieval, that is IR. For this information retrieval application, we have used randomly selected 10 queries. After we have selected those 10 queries, we have indexed our corpuses in normalized index and in unnormalized or regular indexes. So we have searched regular queries from regular index. That means we have searched regular or unnormalized queries from unnormalized index, and we have searched regular normalized queries from the normalized index. So the result shows that the result is shown in this table is the average of those 10 queries, and search from regular index. The average of search from regular index is F1 average is 81.6, and from the normalized one is 89.7. So as you can see from the results that using regular queries retrieved fewest document in all cases, and we have got more relevant documents using normalized queries. So from our IR experiment, we observed that normalization retrieves additional important documents, and as a conclusion, for part-of-speech tagger and named entity recognizer, the regular and normalized model performance difference is not that much significant to decide normalization important, whether normalization important or not important for those parts of tagging and named recognition, because parts of speech tagging, tagger and named recognizer are not semantic dependent, simply label or predict the parts of the sentence. So for sentiment analysis, normalization has a negative impact in all cases where normalization is important for information retrieval. As a general conclusion, the results of the downstream NLP application shows that normalization is highly dependent on the NLP applications and models from the contextual embedding. That is, in our context, that's from Roberta and Flair contextual embeddings are better performed in all cases. As a contribution, the main contributions of this study is this is the first large-scale Amharic corpus that is around 6.8 million sentences, publication of pre-trained embedding models, those listed pre-trained embedding models in both regular, that means a normalized and in normalized way. It uses as a baseline for the coming researchers. And the last one, and the basic one is Python-based pre-processing tools. That is, it includes text cleaner, normalizer, tokenizer, and sentence segmenter. Those all pre-processing tools are using those all pre-processing tools are we can get those all of the pre-processing tools in one package. One simply use pip install amseg, that's Amharic segmenter. So using those one Python library, we can use all of our pre-processing tools by simply pip install amseg Python package. You can get all of those tokenizers free available. All of those our contributions, all of those resources, tools, and datasets are available in this GitHub link. This is all about. Thank you.